Hello everyone and welcome. Today, we will explore the exciting new features and major advancements introduced in the latest release of ANSYS 2025.2. This release brings lots of enhancements across multiple domains, including the new user experience, modular environment, model build, geometry, middle surface, meshing, CFD, isogeometric analysis, crash and safety, and NVH. Results mapping, durability, design and morphing, optimization, electronics, user productivity, augmented and virtual reality. So without further ado, let's begin with the new user experience, where a new settings schema is introduced, replacing the old layouts and adding support for profiles, including team profiles. Profiles offer a cleaner structure, easier sharing, and consistent behavior across different environments. Let's now move on to the modular environment. To begin with, a new versioning approach is adopted for simulation data, ensuring that simulation model variants remain consistent and comparable across iterations. Moving on, the ability to reuse connectors between simulation models stored in DM is now introduced, ensuring consistency and reducing setup time. What is more, the differences between connectors are now listed, highlighting changes in the model assembly between simulation iterations, offering a clear overview of the current setup. Last but not least, regarding the modular environment, simulation runs submission with real-time monitoring of convergence, or key model indicators, on local or remote resources is supported, providing immediate insights into the model's simulation progress. Next, let's focus on another major category, the model build, where several new capabilities have been introduced. First of all, with the newly introduced Seamlines control points, it is possible to define and edit on or off segments, to create intermittent welding effortlessly, and to uniformly control step length in areas of curvature on seam welds. It is also possible to use or project existing model nodes for the creation of the control points. Moreover, double-row symmetric weld root creation is supported for Y-joint shell and overlap shell elements. Regarding the penetration navigator functionality, it is now organized under a dedicated ribbon tab, enhancing this way the user experience and minimizing unnecessary mouse clicks. What is more, the GPU accelerated part classifier is introduced, enabling users to train a custom model to predict any part label based on historical data. In regards to geometry, with the enhanced and powerful loft function, it is now possible to create faces or FE shells from adjacent chains or closed loops to fill gaps in a smart way. Let's now focus on the middle surface category, where multiple new capabilities have been added here too. First of all, it is now possible to easily create middle mesh for overmolding parts that consist of multiple materials, greatly accelerating the modeling workflow. Also, the mid-surface mesh generator can now efficiently simplify the imprinted perimeters automatically, resulting in an optimum mesh result. And when it comes to quad-dominant mesh in casting, we have introduced advanced controls to prioritize minimum triangle generation, better quad orthogonality, and higher length accuracy. At the same time, it is now possible to automatically create interface shells on thick areas as part of the casting tool treatment. Moreover, grouping of similar clips, mesh transfer between clips, adaptation of the mesh to match the geometry of the target clip, and automatic recognition of clips from the DM library, along with mesh adaptation, are now powered by machine learning algorithms, boosting this way the performance in middle mesh creation. In regards to meshing, the new transfer mesh function allows to reuse an existing mesh by matching it from one part to another in similar areas. It works between similar parts located in the same position, mirrored parts, and self-symmetric parts or features. Moreover, the Force Quads functionality is introduced. that enforces the mesh generation, aiming for up to 100% quad-dominant mesh. In addition, Fix Quality can now be applied when clicking on a node in Edit Mesh functionality from the direct group of buttons, making mesh quality improvements faster and more intuitive. There is also this new option that allows to specify the target length of 3D holes in the axial direction through feature treatment, introducing more customization in the meshing process. And talking about holes and openings, we have added a high-precision symmetric mesh option that allows for the generation of symmetric mesh on holes and openings, ensuring overall conformity. The generation of normal triangles is now made easy with just a click with the pattern mesh functionality. Moreover, support of new simplification levels is introduced, the extra draft and aggressive, that enhance the ability of removing unnecessary perimeters. This addition has significant value when modeling subdivision surfaces. It is also worth mentioning that the new options are accessible through the mesh settings and the Simplify Macros function. Also, a new option that forces the creation of user-defined solid element rows in thin walls is introduced, allowing for precise control in the Tetra mesh generation process. Furthermore, with the new domain option of the Define Stack Mesh, it is now possible to automatically build stack mesh within a domain box. This means that you can now effortlessly generate node-to-node hexa or pentasolid mesh, also on voids, like battery foam, electronics, or CFD models, while preserving any existing FE entities if needed. Lastly, the Bolt Mesher is a new hexablock tool for automatic solid meshing of bolts, significantly reducing their meshing time. Regarding CFD, first of all, the hexapoly connection to boundaries with polys instead of tetras is added, along with a new periodicity definition targeted to turbomachinery applications. Box topology and nodal distribution can now be preserved, even after the modifications, to ensure node-to-node matching connectivity. Regarding HexTream functionality, first of all, easier HexTream mesh output is now supported by automatically disabling original geometry in Model Browser. Also, improvements in quality and gap resolution are introduced, along with more controls for layer specs and assigned quality criteria. Moving on to the isogeometric analysis. Regarding the control point modification, live preview adjustment of IGA surface control points for morphing operations and manual Jacobian correction is now made available, enabling more control in the IGA surface shaping process. In the same spirit, support for single and multi-control point modification for unstructured shell elements is introduced. What is more, versatile creation of unstructured IGA shell as BXT for large and complex parts is included. Also, accurate IGA modeling of IGA solid keyword with BREP integration is now supported. And talking about IGA solid, TETMesh -1 and -2 options are now available for PID embedding, eliminating the need to use the tetra.key include file. And also the IGA refined solid option is introduced. Design iterations, by converting FE models into IGA shells, are also added, enabling direct simulation and immediate use in CAD systems, streamlining this way the whole process. Last but not least, it is now possible to identify geometry quality issues early in the IGA workflow of large assemblies, saving time and improving model robustness. Moving on the crash and safety discipline, many new features are introduced. To begin with, the HBM scaling tool allows for the controlled morphing of the bones along their longitudinal direction, with the cross-section remaining constant, allowing for more control in the whole process. One new HBM tool that is introduced is the Inherit Anthropometry. The tool allows for the identification and export of a target model's anthropometric dimensions. And remaining on the topic of HBMs, The articulation metadata can now be input in the HBM articulation tool. In other words, it is not required to load them from the tool. Furthermore, morphing can be applied altogether at the end of the posture assignment trials, increasing this way overall time performance of the positioning process. The second addition to the HBM handling is the auto-positioning tool. The tool assigns regression models-based postures for CESC, Euro NCAP frontal VTC, and UMTRI reclined protocols. To ensure correct positioning, specific nodes and sets must be defined both on the HBM and on the relevant vehicle components. Using these definitions, the tool combines the kinetics from the HBM metadata file with the capabilities of the HBM articulation tool to automatically position the HBM on the seat inside the vehicle. Regarding the HBM to car positioning tool, it is now possible to position human body models in relation to vehicles in compliance with the Euro Pedestrian Human Model Certification Euro NCAP TB024. Remaining on the occupant protection, support for interactive articulation with restraints on the dummy's limbs has been introduced in the dummy articulation tool, making positioning adjustments more easy and intuitive. Also, for cases where the position file doesn't have the same name with the PAMcrash dummy main file, support has been added for the POS file import through the GNS Files button. In the Dummy Humane Ticks Marionette Method tool, two useful options have been added. The first is related to the output options for additional entities. A bundle output of the selected file can be saved in the working directory, or an include path can be added in the main file. The second is related to showing the y-axis angle values of the fake joints for the Thor 50 dummy. Regarding the airbag folder, it now supports a new housing tool for scaling and translating the final geometry to a new initial. The result is the creation of boundary-prescribed final geometry and DIS 3D entities for both LS-DYNA and PAMcrash. Also, when working with more than one tools, it is often needed to transform each in a different way. For this reason, the default transformation can now be applied on a set. Regarding the pedestrian tool, it now supports the BLEBS-RL custom intersection option in the advanced settings for the marking based on legal regulations. Also, in cases where BLE and BSRL have multiple intersection points, the tool is going to consider only the segments of the curves that make the impact area small. Regarding the FMVSS201U tool, the ability to position around the target points with manual operations has been supported. Passing to the low-speed tool, the update here is related to the regulations ECER 42, US Part 581, and GB 17354, and the advanced options of the Target Points tab. The Y-offset mode field now supports three options, which are the distance from center, the percentage to corner, and at extreme corner. Furthermore, regarding the bus rollover tool, creation of survival space for the driver as per ECER 66 standards has been supported, along with the inclusion of templates in survival space as per AIS 031 standards. Also, support of include naming has been integrated into the entity cards, allowing users to have an overview of where each entity belongs to. Last but not least, the rigidize function can now be applied on whole include entities when working from an include list and through the connectivity context menu, guaranteeing this way model integrity. Passing on to the NVH discipline. Here, Actran Aeroacoustics is supported in pre-processing, offering the ability to set up an ICFD analysis. In regards to results mapping, in the results mapper, the nodal forces from CSV files can now be mapped on solids, ensuring equal resultant force between source and target. Moreover, enhancements have been introduced in the solver files format. These include the fact the MetaDB results files are now supported. Additionally, a new option to select specific PIDs as source is now available. Moving on to the durability discipline. In oil canning, a new functionality is now available to improve the user experience. With this new functionality, target points can now be created based on raster projection, or by loading them from a CSV file. Additionally, template-driven definition of the contact, step, and boundary conditions can be performed. Let's now see the improvements. In the cross-section tool, these include the improved visualization for section forces and moments, the fact that the neutral axis is now drawn in all stress result view modes, and a new fringe bar widget is now introduced that allows the specification of the number of colors used to draw the results, enhancing this way the whole user experience. Lastly, the orientation vector function has been enhanced with a new option to align beams coordinate system normal to shells or faces. In regards to design and morphing, in version 2025.2, the existing feature function has been enhanced with parameterization capabilities and is now available under the name PM feature. Users can create, on both FE and geometry models, features such as openings, flanged openings, beads, stamps, and ribs, enabling fast and consistent updates without the need to recreate them. Moreover, fully controllable dimensions are provided through the creation of a PM feature entity, significantly improving workflow flexibility and reducing manual rework. Last but not least, PM feature entities can be connected to the optimization tool, allowing them to be used in optimization and DOE studies. In addition, a new option has been added to morph parameters. Users can now automatically create annotations for each stored parameter through the parameters list, displaying its name, type, movement, and other characteristics, making it easier to view and manage them. Finally, the record functionality has been implemented for the following morph functions: DFM, deform map, fillet, and form. Users can now record their actions with these functions and automatically generate the relevant scripts, which can later be used for automated processes. Other major enhancements are introduced in the optimization field. First of all, quick responses can easily be set up in an optimization workflow using the new fast post-processing task item. Users can select simple responses from the most common load cases, without the need of performing a baseline run and record a meta session. Currently Nastran Sol 101, 103, 108 and 111 are supported. Also, 2 new solver formats are supported for the FE output, the Fidelity LES and the Meta FRF assembly. In the DOE, new DOE studies can be set up with the custom option. User-defined sampling algorithms, written in Python, can be employed to create experiments. Moreover, 3 new optimization algorithms have been added in the ANSA optimization tool. These include the Limited Memory BFGSB, a gradient-based algorithm, the Simplicial Homology Global Optimization algorithm, and the Multi-Objective Evolutionary algorithm with differential rule, offering greater flexibility in the optimization process. Regarding the RSM setup, if the ML Toolkit add-in is installed, RSMs trained with the Kriging method will also have KPIs available. These include accuracy metrics, performance plots, and model explanation plots, allowing for better overview of the process. Furthermore, complex expressions between all available variables can now be defined for constraints and objectives of direct optimization studies. And last but not least, in the area of results post-processing, users can now process DOE or optimization results by merging the existing or by copying data from existing tables and pasting them to new empty ones. In terms of electronics, primarily, bending of rigid flex PCB models is now supported. Bending information, that includes bending curves and areas defined in IPC 2581 files, are automatically taken into account to generate a ready-to-run PCB task, including anchor points and bending actions. This task becomes available after running the ECAD import, and when executed, the PCB obtains its final bent position. Moreover, support for IPC 2581 Revision C has been expanded to cover all levels of board detail. Until version 2025.1, support was limited to trace mapping and full 2D metallization. But now, the addition of rigid flex bending support provides a complete and consistent representation of the board. Also, the independent selection of source components for pin and package projection onto the board is now possible, both in GUI and non-GUI modes. It is worth mentioning that this possibility is independent from the import of the component itself. The performance of the ECAD importer has been significantly enhanced as well, for both full 2D and 3D metallization levels of board detail. This improvement is achieved by accelerating the 2D topology processing stage. Last but not least, the reading of solid mask layer has been expanded from trace mapping to all levels of board detail. Having seen the improvements in electronics, let's pass on to the ones that accelerate user productivity. To begin with, enhancements have been introduced in the Renumber tool, including the ability to generate a new plot for unused IDs. It is also possible to hover highlight in all IDs graph plots and automatically detect clashing entities when setting up rules. Additionally, encryption capabilities both for LS-DYNA and Abaqus entities are introduced. And talking about LS-DYNA, several keywords have been supported dedicated to ALE and airbag. Also, the mat add options are from now on visible within the material card. Regarding solver submission, job submission on local or remote resources is now possible with real-time monitoring of the convergence or the key model indicators to observe in real time the solving progress. Moving to the Abaqus Loadcase Assistant, the tool has undergone significant improvements in data management, making it easier and more intuitive to organize steps in loadcase entities, greatly enhancing the overall user experience. Loadcase entity types can now be grouped at a deeper level, enabling better handling of large numbers of entities. Furthermore, vertical column headers and step separators have been introduced, improving this way the visualization. At the same time, configurable step column visibility is added, using the dedicated Show Hide Columns icon. Moreover, a new context menu allows activating or deactivating entities across multiple steps, streamlining user actions. Finally, background colors now clearly indicate whether an entity is active or inactive within a step. What is more, a new function under Abaqus Materials List to suppress specific subkeywords is now introduced. The suppressed keywords appear with a strikeout on their labels within the material card. During output, a relative message is also printed in ANSA info window about the suppressed keywords. Regarding the annotation tool, it has been fully redesigned to align with Meta, ensuring a consistent user experience between pre- and post-processing. Last but not least, the Cut Plane tool has been enhanced with an options list that opens directly, allowing for better control. Also, the live preview during the creation of the cut plane and the interactive edit facilitates the accurate positioning of the plane. Passing on to the augmented and virtual reality category, where here, the hands inspection functionality is introduced, offering the ability to choose between female or male size adjustable hands with real-time occlusion with models. And with all these new features and enhancements, integrated in ANSA 2025.2, this video comes to an end. Thank you for watching.